In this video, we are going to create another event loop, but this time we're going to use Python and the Tornado web application framework. And although it includes everything from WebSockets to HTTP servers to HTTPS servers to all sorts of utility functions, what we're really looking for here is just the core I/O loop, which follows the same principles as Node.js, as libuv, as any of the other evented I/O examples that we're going to be looking at in this playlist. So the first thing we're going to do is create a virtual environment. And it's going to take a minute to complete. It's just creating a local distribution of Python and all the dependencies that we want so that it doesn't have to muck up the system copies. And it also allows us to work within our possibly limited permissions. So now, oops, we have to assume that virtual environment first. So now we're working in that context, so we're going to install a copy of Tornado. And we should write an updated requirements file. Okay, now we can start working. So from the IO loop submodule, we're going to import the IO loop class. IO loop class provides a static method which will return and handle to the current default loop instance. So in this case, we'll call that. And if we wanted to start an application that will just run forever and do nothing, then that will be enough. We're not going to do that, however. We're going to set up, like our other example, a repeating callback that prints something to the console. I don't know or think there's a method that will let us do a repeating callback, or a periodic callback maybe it's called in Tornado, but we can manually do it in this manner with timeouts. Timeout will accept, I think, either a microsecond argument, or in this case we're going to import time delta objects, which are handy because we can initialize them with keyword arguments like milliseconds. So we will say, after we print that string, we'll add another timeout, 2000 milliseconds in the future, 2 seconds, and the second argument is the callback. So take that line, oops, and that's also how we'll start it off. So now, this Tornado-based example is like our first example in libuv, running forever and doing the same thing. Ideally, it's going to be asleep and not doing a whole bunch else in between these print statements. So let's open up API Monitor and verify that. API Monitor will let us observe the call stack and watch the threads that are active and see what's going on here. Is this? There it is. Alright. So now we can observe every call or every system call that's happening and every library call that's happening. And it looks like we'll see some parsing by Python, as it's a scripted language, it's always interpreting. And the crux of it is right here. Or we exist in a select statement, which is awaiting an event. This is simply going to be waiting for the next 2000 millisecond callback event, and once that happens, it's free to start writing. In this case, this will be the statement that's going out to the write file is writing to standard output. We're done with that for now. So what we observe is that ultimately what's happening is between these timeout statements, the one thread, that is the Python interpreter, is sleeping and holding as we would desire, polling for the single event, which is going to be the timeout, which will wake and then execute the next callback event. So in terms of performance, we don't actually lose that much in moving from a compiled language like C to a scripting language like Python, so long as we think in this evented manner. Code that's been ideally optimized or JITted in some way is going to run pretty much at par with native code. That's the conclusion of this video. In the next video, we're going to look at Node.js and see how it does it just a little bit more cleanly, but again, follows the same principle and is in fact based on libuv.